Hi, everyone. We will give everyone a couple of minutes, maybe a minute or so to dial in, and then we will get started. All right. Thank you so much, everyone, for joining us today for our webinar on Shift Left or Squish Right, Getting Time to Test. Shift Left testing recommends reversing the testing approach and involving system and software testing earlier in the lifecycle. Practically, it means moving the testing approach to the left end of the project timeline. But programmers are not motivated to stop coding and then they spend days on deep testing. They may just perform some simple output checking, but deep testing may never happen in a shift left regime, which then forces that testing to the right into the world of customers. So how and when do you get time to test? Ladies and gentlemen, I'm Shubhendu. I head the global marketing team at Cigniti. I wanted to give you a quick intro about Signity before we get started. Signity is the world's largest independent quality engineering services company working with Fortune 500 companies globally. We bring the power of AI into Agile and DevOps to assist enterprises in accelerating their enterprise digital transformation journeys. We host a lot of thought leadership events focused on quality engineering, enterprise transformation, and many more across diverse industries throughout the year. I'm really pleased to welcome all of you, and I wanted to take a moment to introduce our speakers. Our first speaker today is James Bach. James is the creator of the rapid software testing methodology and is the author of Lessons Learned in Software Testing. He began as a developer, but became a tester at Apple Computers in 1987. He spent the 90s researching testing as if it were a social science. James is the CEO and principal consultant at Satisfice and a co-founder of the context-driven school of software testing thought. He truly brings vast experience in the field of software testing and influences the way individuals and companies think about testing. Hello, James. Welcome.
Hello.
Thank you, James. Our second speaker is Mr. Konda. He is the president of Signity East Division in North America. Kalyana is a software industry veteran, a leader, and an agile software testing expert. He has an in-depth understanding of client expectations, feedback, new requirements, and roadmaps. He is instrumental in driving enterprise transformations at diverse organizations. He is a strong proponent of IP-led testing services, and he has a pending patent in the area of intelligent test scenario generation to accelerate software testing lifecycle. He has enabled global delivery teams to provide best-in-class services to our customers and has ensured client delight across all the operating industries and geographies. Welcome, Kalyana. To all the attendees, at any point during the webinar, if you have questions for the speakers, please find the panel on the right side and use the chat tab. There is a little button with two bubbles, speech bubbles. That's the chat tab, and we will cover them at the end of the webinar. I would now hand it over, without any further ado, to James to take it forward from here. Over to you, James.
Okay, here we go. Okay, well, DevOps and testing can be quite challenging. And I want to tell you why that is before I tell you what I think we might be able to do about it. Let's see, hit that button. There we go. I think it becomes clearer if you realize what DevOps should have been called. It seems to me DevOps is a pretty bad name. But once I realized what DevOps really is, I realized there's a much better name for it. DevOps simply means development with delivery. Development combined with delivery. It should have been called DevLivery. I would have named it DevLivery if I had been in charge of naming things. So once people realize that's what DevOps really is, that's the only big difference. Now, there's other things about DevOps that don't necessarily have to do directly with delivery, but taking delivery and melding it with development is the thing that I think is really different from the way we used to do things at Apple Computer or Borland International, where I used to ship products way back in the 90s. We didn't have to worry about going live every day. We had time between developing the product and delivering it. And that time in the test group, we exploited to get more testing done. And there is something that happens after you think you've done something, but before you deliver it. And in different industries, this has different names. Proofreading, clinical trials, if you're talking about a vaccine. Do you know that one of the vaccines, I think it's the Moderna vaccine for COVID, was actually created in a weekend? You talk about agile. They created it in January. They created it a year ago. Why didn't they release it a year ago? Because they had to test it. They did a whole bunch. They did months and months of testing before they decided, okay, we can release this thing. But I found that really interesting, that it was actually created very, very quickly by the technology and the equipment that they have. In many fields, this process, after you think you've done something, but before you inflict it on people, is called testing. And it's called testing in our field. But what happens to testing in DevOps? Well, I grew up in Vermont, and we have bears in Vermont. And I was always told as a child playing in the forest that I might see a bear because they're around. There weren't a whole lot of bears in Vermont, but there were some. And I was always told, you got to be careful with bears. They're very dangerous, or they can be dangerous. And especially mother bears. You don't want to come between mother bears and the bear cubs. If you're between them, the mother bear can attack you. If there's a threatening creature, say a testing expert who may come between them, he may get attacked. And this is a useful analogy of what can happen to a tester if the tester tries to get between development and delivery when people are trying to do DevOps. And as you see, this has shifted left. There we go. You notice the tester is now on the left of the bear, but also not in very good shape. This is my experience when I deal with clients, when I deal with my testing clients, my students who are telling me about how, well, they just tell me that we have to shift left, and what that seems to mean is they don't want to do testing anymore. They want to automate everything, except that they haven't given us time to automate. Yikes. So that's my experience with this. Let me say a little more about that. Shift left is not supposed to mean that. It's supposed to mean that testing is highly integrated with the development process. In other words, you're supposed to ride the bear, not get stomped on by it. for the most part in DevOps, what I keep hearing is people say, well, we want to deliver every day, or we want to deliver so frequently, there just isn't time for manual testing. Of course, I'm wondering, what about manual coding? Or what about manual engineering? What about manual management? All of that stuff is still done by people. Somehow only when people talk about testing do they think that you don't need to have thinking people doing testing who are paying attention to the product as they test it. So they just tend to think in terms of automation. And automation is interesting. I am a programmer. I am currently working on a tool for Tricentis. So I've actually gone back to coding after being out of coding for a lot of years. I'm now spending half my time writing software again. And so I'm not opposed to automation. I live with automation. But the problem is deep testing cannot be done that way. Shallow testing, simple testing can be done substantially with the support of automation. It still needs humans. I would say you can't actually automate testing any more than you can automate being a parent by giving someone an iPad. You know, you give your child an iPad if you're a parent. That's not automated parenting, even though it might give you some breathing room. Might give your child something to do for a little while. You're not automating the parenting process by doing that. You're not automating the management process by giving somebody a to-do list and saying, follow the to-do list. That's not automated management either. But you can do shallow testing. And when I say shallow testing, I mean testing that is going to find some bugs that are easy to find, but not necessarily the bugs that are difficult to find, using automation to help you do that. You still need a human to review the results, and you need a human to put the system in place. And even though you have that human, the system is going to churn and churn, and there could be lots of things that happen that the human's going to miss. But you might find things too. Still, deep testing, the kind of testing that finds elusive bugs. I don't know any way that we can test deeply when we're not given enough time to experience the product and when we're expected to turn everything into a test case. I do a lot of testing. I've done a lot of testing over the years. I've tested medical devices. I've tested video games. I've tested all kinds of things, e-commerce systems, embedded systems, navigation systems, whole bunch of things I've tested for my various clients. And I love deep testing. And every project is unique. Every project is intense. And it's laughable to think that I can just write a few test cases and it's somehow going to find all the important bugs in an HP printer, for instance. But you know what? They've tried to automate HP printer testing for years and years. They brought me in the year 2000 after they'd already been trying to automate it for 5-6 years. And it wasn't working for them. And I told them, look, you just can't automate this stuff. And they said, we want to keep trying. And they tried for a few more years. And eventually I got a phone call from the manager of the firmware quality group at Hewlett-Packard saying, we think you're right. We give up trying to find all the bugs with automation. I was very pleased to hear that. But then they changed out that manager. That manager retired, and then a few years later, another manager came on, and my understanding is they're back to trying to automate everything again. So what can you do? Now, why can't we test deeply? I can't test deeply early if I shift left and I'm dealing with a product that doesn't fully exist yet, because I don't know enough about that product. That's one thing. Because I don't have the time to produce. That should say produce. See this? You can tell this is the first time that I've done this thing publicly. It's brand new material, and I have to say produce. There we go. I'll fix it. Produce complex data. And I can't automate experiential testing. When I say experiential testing, I mean the process of experiencing the product. I saw some automation the other day, which I had challenged a colleague to create, which went onto a Kanban board and was moving cards around. I wanted him to write a program that would move the cards around, add cards, delete cards. And his automation broke as soon as I decided to add more than 6 cards onto the system. Why did it break? Because the cards couldn't be seen on the screen. It scrolled the cards up. But the automation still knew where the card was. So the automation tried to grab the card and drag it. But because it was off the screen, it couldn't drag it. But it thought it was dragging it, because it could see the thing in the DOM and it executed the code to drag it. It failed, and then it thought it succeeded and went along happily and declared that the test had passed, even though it hadn't. Experiential testing is when you work with the product in the way that the customer is going to work with it, and you experience what the customer is going to experience. And it's a very important part of testing for very complex systems. It's not necessarily important for all systems or for simpler systems, but for anything that goes to a human customer and involves a human customer having a nice experience of using that software, there's no substitute for experiential testing, although automation can be helpful. Testing deeply requires experiencing the product, the entire product, under natural conditions to do realistic things with socially competent evaluation. Now, notice what I say there, socially competent evaluation. Socially competent means when you see a bug, you have to decide whether it's a bad bug or not a bad bug. And the machine can't do that. Any code you write can spot things that maybe are wrong, but they might not be wrong in any important way. With socially competent evaluation, the tester doesn't just report a bunch of stupid bugs that waste everyone's time. And I'm doing that when I experience the product automatically as a human. And finally, we're supposed to ride the bear, but it turns out, in my experience, bears don't like to be ridden. They don't want to give rides. In other words, if I shift left and I talk to a developer about testing, I find the developer usually doesn't want to talk about testing. Developers usually don't want to think like testers. They want to be optimistic rather than pessimistic. They don't believe that things can go wrong. A good approximation for what it's like to talk to especially younger developers is to have a child and then have an argument with your 7-year-old son, as happened to me, about what the right way is to pronounce an ordinary everyday word, and have your son tell you that you don't know what you're talking about, that he's pronouncing the word correctly and you're the one who's wrong, Dad. That's what it's like sometimes to deal with developers and marketers and entrepreneurial managers. Testers, our job is to believe in failure, and everybody else's job is to believe in success. And that's important for them to believe in success. I told you I'm writing code. Well, I was up late last night writing code, and when I was writing code, I was thinking like a developer. I wasn't thinking like a tester. I have to think like a developer in order to get things done. I have to have faith in my tools. If I think like a tester, I don't do very much because I'm constantly thinking, well, how do I know? How do I know it works? It interrupts my development process. That's why when I'm developing, I like to have a different person do the testing, not me, because it clouds my thinking. If I'm all alone, then I have to stop myself at a certain point and go into testing mode, and then I have to think like a tester for that period of time, and that can be difficult to do for my own code. But it is a different mindset. Here's what I mean by squish right. I want to test a product that's fully available, that I understand, and that I am fully prepared to test. But here comes the bear. The bear says, no, you don't have time. And what does that do? That means that I either get squished to the left or I get squished to the right. It's not so much a shifting as a squishing. The squish happens because management says, we're just not going to give you any time. We're going to give you an hour to test, and then we're going to release the product. What that does is it forces people all over the industry to test in production. It means that they're forcing their users to test, but it means that the testers try to catch up as well as they can by testing after the deployment has happened, which that can be okay depending on the kind of testing you're doing. But of course that can be a disaster as well. And we can do stuff, we can shift left and we can do stuff to the left as well. We can do whatever we can do. We can review things. We can try to talk about risk. We can review code. There's always various things that we can do. My point is that nothing I can do before I have seen the entire product and experienced it allows me to find every kind of bug that matters for me to find. Yes, I can prevent some bugs. Yes, I can find some bugs early, but there is no technology for finding every kind of bug that matters for most kinds of technology that it matters that we test, except after the product is fully available with realistic complex data to work with. So what do we have to do? So that's the problem. What do we do about it? Well, my first solution is I push back. I push back. Now, it's easier for me to push back because I'm an older guy. I'm an older man. I've been around a long time. I'm very confident in myself, and I have a loud voice, and I can speak up. So I say, wait a minute. You might want to ship the product, but here's some reasons why you might not. Let's talk about it. And they talk about it with me because I'm not going to let myself be pushed away or pushed down. I'm not going to stay on any project where people aren't listening. And that has some risks that come with it, of course. But one of the things I know how to do is I know how to talk in the language of bears. And testers need to learn this. And I find a lot of testers don't know how to do this. But you got to practice. And this is the main thing. You've got to talk about business risk. Now, it's possible, or it's reasonably common, unfortunately, that management doesn't even want to talk about risk, even if you are talking in the language of business. They just don't want to hear about risks at all. But there are a lot of businesses that are quite willing, quite reasonable, and quite willing to talk about risk with you. But you have to know how to talk about it. I need to be able to say, there's a certain kind of bug that I need time to find in the product. And I need to be able to describe what that bug is, the kind of bug, and how it might impact customers. I need to do this with imagery. A lot of people think that you need to do it with numbers and probability equations, and that's really not how people think about risk. People evaluate risk based on imagery, vivid and plausible imagery. So I need to convey a proper sense of dread of the bad things that can happen if people don't let me test. Part of how I do that is I collect stories of real bugs that have happened in the field, news stories, and I show those news stories. We also do market surveillance. So one of the most powerful things you can do is keep track of problems that your own customers are seeing. Pay close attention to that feedback and show that and say, these problems have got into the field and people are upset right now about this. Don't you want us to find these before it's too late? Now, of course, people may say, well, that's why we should have even more automation. So then you have to go to a conversation about why there's no amount of automation that you could have that would anticipate bugs that you can't anticipate, that you don't imagine right now. And this is one of the problems with talking about risk is dealing with bugs that you can't imagine or you don't yet imagine. So that's why that's another reason why experiential testing is so important, so that you can get a hint about potential bugs, and then you can spin some stories about what might happen. We've got to be able to answer questions like this in these conversations. What sorts of problems will escape our mechanical output checks? What are some examples of those? Take them through a picture. Draw a picture for them about that. Why are those problems possible? Why can't we just prevent all those problems? What's the worst that can happen? And what do we do if the worst happens? So usually for a lot of products, the thing that's the worst that can happen is data loss, your customer data loss. And so I usually focus on that. Data loss, sometimes scalability is the worst thing that can happen. If you're selling concert tickets, for instance, or vaccine appointments, then scalability might be the worst thing. But usually it's loss of data. It's not even that the program crashes. It's that your data gets corrupted. So I try to be aware of the various laws about privacy and security and that sort of thing, so that I can get management to give me a little more time to test until I feel like we've done a reasonable job of it. Now, this is the last bit I want to show you. Imagine this curve. If you go too fast, you're in trouble. If you go too slow, you're in trouble for a different reason. One of the reasons why you're in trouble if you go too slow is that you lose track of what's happening. Like, imagine that you do an hour of engineering on a project every week. Well, then every week comes around, you try to do another hour of work, and you've forgotten your previous hour. Things go out of your head. They get crowded out by other things. You need a certain amount of focus and a certain amount of speed just to keep people interested, just to have them lubricated and up to speed, if you will, and not distracted all the time. But if you're too slow or you're too fast, I'm going to call those zones of regret. We want to try to find that zone of power where we have maximum productivity. So if we're too slow, we'll be drifting. Past a certain critical point, we'll be productive, but maybe we'll be too cautious. If we go too fast, we'll be reckless. Now, the bear defends us against going too slowly. As a tester, I'm trying to defend against us going too fast. I'm trying to be a voice that says, watch out about these risks. That's my job. Is I want to keep us in the zone of power. I don't want us to go too slow either, but my focus is on slowing us down and marketing and and the CEO and the developers, they all want to push to go faster. But notice something. Notice that the market sometimes can't even move as fast as you need to move. That happens sometimes. For instance, you all have experience of having apps that get updated and updated and updated every day, or you get, yet another Windows updates comes through, and you have to reboot your system and accept the updates, and then do you really need that update? I think sometimes people are innovating actually faster than anybody can process that, and the customers often would rather that you just slow down and get it right. But maybe you're going that fast because you're excited. Your engineers are there and they want to get stuff done, and they can't go any slower. But that's not the problem I'm really concerned about. I'm concerned about this problem more. This is a much more common problem where management feels that we have to go a lot faster than we can safely go. And this is a big reason why DevOps turns into testers getting run over. This is exactly the scenario of I'm between the cubs and the bear. The bear wants to run over me to get to those cubs. Let's say the cubs are products being delivered to the market. And imagine it like this. It's like you're trying to drive to the hospital and you have a dying child in your passenger seat. If you get to the hospital in time, the child has a chance to live. Does that mean you're going to drive recklessly? Absolutely. I am going to drive faster than I can safely drive. I will do that because the child's life is more important. Even a chance of that. I was actually driving my wife to the hospital a couple of years ago, and I was stuck behind a car, and I was thinking about this exact thing. Do I swerve around this guy unsafely? Or is it okay? My wife had broken her leg, and I was worried, but I decided that it was 30 seconds delay would not be too much of a problem, so I decided to drive safely. But what we at least have to do as testers, what we at least have to do is we have to explain, look, we can take risks. We can take risks and we can go into the field with a product that's not very well tested. But it's my job as a tester to explain to you what could happen. And then you, management, you make the decision about what you want to do. I don't control the business. I'm a tester. I remind this, and when I'm a tester, I remind my clients, I'm not in charge of when we ship. I don't control. I'm not the gatekeeper. I'm just the guy who warns you. That's my job, to warn you with information, with data about our product, good testing. Now, sometimes, this is the very last slide. Sometimes people say, but James, Google, Facebook, Amazon, large, rich company X, they got rid of the testers. They deliver every day. Well, don't compare yourself to those companies, because those companies can't go out of business anymore. They can't. Everybody relies on them. They have a business model which allows them to ship bad software, and they'll be fine. There's a website called Killed by Google. It lists 224 projects that were canceled by Google, many of them huge projects. They must have lavished millions of dollars, millions and millions and millions of dollars on these projects. And then they just abandoned it. If you can afford to do that, Google, good for you. It would be hard for me at Google to say, well, hey, we better be really careful about testing this because otherwise we'll be in big trouble. Because they just shrug and go, what do you mean big trouble? People We can have big problems, and it might even become a big news story, and we just kind of shrug and go, well, what are you going to do? Get rid of Google? They have the luxury of operating irresponsibly. If you also have the luxury of operating irresponsibly, then definitely why test? You only need to test if you care about there not being embarrassing, damaging bugs that your customers see. If that's what you care about, then you will test. And there's no one who's going to get around that need. Shallow testing might be good enough in your project. My concern is for deep testing, which requires more than what can be done with automation or with shifting left. So that means that I have to know how to have a conversation and assert myself and give examples of stories of important problems that have happened so that I can create enough responsible dread in the hearts of the people I work with so that they will say to me, you're right, James, this does need more testing. We should delay and test this for a little longer until we feel more confident that this isn't going to have a big problem in it. And then if we release and it does have a big problem in it, and they come to me and they say, Tester, you said we'd tested enough. It has a big problem. Why didn't you find that? I say to them, no one can guarantee that we'll find every bug, but there is one thing I can guarantee. I guarantee that I will learn from every bug that gets by me. I take every bug that gets by me personally. I don't promise to find them all, but I try to find them all. And if anything gets by me, I will learn from it. I will become a better tester. And that's a guarantee I give you. And nobody can give you a better guarantee than that. We're all stuck with that as the gold standard. And we just try to keep doing better. All right, that's my presentation. Thank you for listening. I'm ready to pass it over.
Hey, thank you very much, James. That's really great in terms of how testers really have to behave in project situations. Some great examples. Loved it. Being a tester myself since the beginning of my career. Just a little bit about Signity. For the people that are on the webinar. So we are the largest independent quality engineering services company, a global company. Currently, as a company that we just focus on one thing, that is software testing and quality, and do that thing really, really well. And 50 plus Fortune companies actually depend on us in making sure that their clients are getting what they deserve, and also that as a company that we are also known for sort of educating and building the software testing communities. So Signity as a company, we run many testing groups in different cities, and that is our way of giving back to the testing community. As a company that we build the entire company just on software testing and quality, and we want to make sure that we give it back to the testing community, so that as a software testing tribe, that we continue to grow, and also that we continuously innovate, and we are actually preserving and advancing the testing craft, right? That's really our goal of doing some of these knowledge sharing sessions. So I'd like to offer my perspective around the both shift left and situations. So when we are working with clients, and very often we get a pushback in terms of involving the test engineers early on in the development life cycle, right? And many times the project teams or the management teams see that as a burden to the overall project, and because there is very little that actually the testing teams can contribute by actually participating very early in the life cycle. While there is not a whole lot that can be done by early testing, obviously by getting involved early during the requirements phase, we believe as a company there is a lot that can be done as well. Otherwise, there are lots of problems that can be caught early in the life cycle, and quickly, and also in a cheaper manner, as opposed to finding them later on in the life cycle. And having said that, we also don't believe that actually early testing is a silver bullet to all the problems, right? Meaning that just by starting early, you're not going to find all the defects that are out there. And like James mentioned, that there are a lot of things that are not there yet for a tester to do this exploratory or experiential testing, because you don't see what you have to see in a full scheme of things, right? So we believe that there is a space for shift left, there's a space for shift right, and also the testing in the middle of the development life cycle. In terms of more and more what we are seeing, especially in the context of both agile and DevOps, is that because of the way the pod teams are being formed, there is a lot more collaboration, and also that actually this sort of methodology allows the test teams to closely interact with the rest of the project teams, be it developers, business analysts, and scrum masters, and all of them early on in the life cycle. However, the testers also have to raise their game, and then find ways on how can they contribute early on in the life cycle, because many times some of the things that I hear from the clients is that, yes, we are getting test teams involved, and they are mostly listening and understanding as opposed to contributing it right now, right? But however, the management wants to see what is the return on the involvement of the test teams early on in the life cycle. So, and actually based on some of the data that we gathered from the projects, the numbers can be deceptive, but then based on the thing, there are almost 3 out of 10 defects can be found early on in the life cycle, and that has the potential to actually translate into many more defects, and also can become a lot more complex down the life cycle. So obviously, as a test team, that we need to, as a testing community, we need to figure out ways of how can I contribute by being involved early, right? So some of the things that actually that we figured out, and that we use it in some of our projects, is that one is that the testing is obviously a very intellectual and challenging job. It just cannot be reduced to a templates and a checklist, right? And template and checklist is not a solution for not thinking intelligently. But however, you also need a map. I would look at some of these templates or checklist as a map, and while the test teams have to figure out the path or the intricate details of each and every project by applying their own intelligence. So some of the things are the type of defects that we were able to find are related to the clarity of the requirements, and the consistency, and the completeness, and more importantly, testability at the requirements phase or at the use cases stage. So what we are doing is that this actually one, it helps us to actually to force the rest of the teams to think a lot more clearly. And at this phase, it also benefits the entire team if you can find some of these issues early in the life cycle, because not only the test teams are now working with a cleaner set of requirements, and which actually helps you to direct your test effort much better. But also it helps the rest of the team, because then the rest of the team is also especially the development teams are also working from a cleaner set of requirements, which means that they also now have we are actually indirectly helping development teams to write better code, because we are actually helping the teams to develop the requirements that have got a better clarity, and where the usage of the terms are consistent across. So there is that sort of that will have an impact on less confusion, and or lead to not a lot of interpretation, a different interpretation that can lead to defects, or also in making sure that the requirements are defined a lot more completely, and more importantly, that we are also forcing the teams to write requirements in a way that you would be able to define write either the manual test cases or automated test in a way that actually that they can be tested better, right? So these are the aspects that we were able to drive in various projects, and also that what we just to one actually James talked about why is it important that we paint a picture. And yes, painting a picture is very important, because people glaze over the numbers, but they can actually that whole images can stay in the brain, and so it also makes sense to basically, depending on the kind of projects that you are in, and when you are actually reviewing a large set of requirements, and we have to have a way to communicate in an objective manner of what are those requirements that are written better in comparison to others. So we could actually come up with something called a requirements ambiguity testing index. I'm just making up here something like that, and then assign different weights to each of these parameters. So it actually helps you to normalize all these requirements, and thereby you are able to clearly communicate to the rest of the teams on the requirements ambiguity index level where each requirement stands. So that's a little bit about my view on what can be tested early and how is it beneficial, and then actually what testing community has to do so that the rest of the team members in the projects actually welcome our involvement early on into the overall life cycle, and by adding real value to the project teams. So So that's that's the that's my talk, James. We actually have about 10 minutes left, James, and I see that there are many questions. Would you like to pick up any and answer?
Yeah, I was just crawling through the chat
Sure.
records backwards and typing out some things. One of the things you just said was you talked about identifying ambiguous requirements. Do you know why requirements are ambiguous? Do you have a sense of why they're ambiguous in the first place?
I could be various reasons, because the software systems and designs, they are complex, and they evolve over a period of time, and they also some of these ideas are getting brainstormed, and the user needs are changing. So those are some of the reasons that I could think of, James, in terms of
Okay.
why
Well,
they can
one of the things I do in my classes is I encourage people to think about ordering food in a restaurant.
Yeah.
Like, say you order a beer in a restaurant, and you say, "I want a beer," and the waitress says, "Okay, I'll bring you a beer," and she brings the beer and she pours it over your head, and you say, "That's not what I wanted," and she said, "You said you wanted a beer," and I go, "Oh, well, I thought you knew I didn't want it over my head. I thought you already knew that." And she goes, "Well, you have ambiguous requirements. You should be more specific." So I say, "I want the beer in a glass." So then she goes away and comes back, and she puts a glass in front of me. It's a tiny little glass, like from a doll's house, with 3 drops of beer in it. I'm like, "That's not what I wanted." She said, "You said you wanted a beer. You said you wanted it in a glass. You didn't specify how big it was. Why are you being so ambiguous?"
Yeah.
And now the lesson here is not that you should always be completely specific about everything you ask for. The lesson here really is when we're ordering in restaurants, it goes well because we're ordering from people who have what's called tacit knowledge. They have silent knowledge that they share with us that allows them to know what we meant when we asked for things.
Yes.
So we use tacit knowledge to limit how much we have to write down. Otherwise, like for instance, you don't want to have to say, I want to have this user interface with this stuff. And by the way, I want to be able to copy and paste. You don't want to have to say that. You want people to just assume, of course you can copy and paste. Why wouldn't you be able to copy and paste? So I think that one of the reasons why requirements are ambiguous is because it's very expensive to make them totally unambiguous. That's extremely expensive. And it's also not necessary because people usually know what you mean.
Yeah.
So one of the challenges in creating requirements is to have shared experiences across the team so that you can gain that tacit knowledge that, like maybe, like I'm designing a test tool right now, and one of the things we're doing on my team is we're using various test tools that our competitors have come up with or the open source tools so that we can say, I want a feature like that. And that we all know what like that means because we've all used the tool. We've all had the experience. So one of the ways to get around this problem might be to have more shared experiences and then try to write the requirements. And then maybe it'll be easier. But you know, one of the problems that you deal with every day, I'm sure, is that you are a services company, right? Yeah. That means that you have teams working very remotely, 5,000 miles away from your client, and you aren't on their team, and you don't have a lot of shared experiences. So in your case, you actually need more specific and unambiguous requirements, right? That's a key thing in order to work in the mode that you want to work. In fact, we're all stuck that way because of COVID. So many people are working remotely. And because we're working remotely, a lot of the ways that we were able to deal with ambiguous requirements, we now can't use because we're not seeing each other in the hallways, and we're not having lunch with each other. We're not ordering beers with each other. So it's all the more important to be able to talk and be specific. So what I would say is, it's not that we always need ambiguous requirements, but we need the skill. We need the ability to get more specific when the risk says that that's what we need to do. We need to have these tools that you mentioned and these practices ready to go that we should use when needed. The judgment part is, when is it really needed?
Correct. Yeah. And also that how specific you want to be, so that we also don't want to write one-liners, and also we don't want to write a thick book of requirements. So
right.
Because nobody has unlimited amount of money, because we're all trying to get the work done in the reasonable time and money limitations, and in the context of what we are dealing with, like you have rightly mentioned, and if we're all working in a room, and we probably can live with very little to no documentation. But however, if you are collaborating as a team globally, then there is a need for a lot more. So it is all like, you are the person that started the term, coined the term, inventor of the context-driven testing, and that's exactly what it is.
Yeah, I was on a medical device project some years ago, and I was forced to write documentation for my automation that I created that automatically analyzed a bunch of statistics. That we had gathered the data experientially, interacting with the product. We gathered millions of data points, and then I wrote software that analyzed the data. And it was power accuracy data. And then I was forced, because it's a regulated project, I had to test and document my test tool, which normally I wouldn't have had to do. I would just tell people about it. But because I had to document it, I was writing down carefully what it did. And while I was writing, I realized that we had missed a huge part of the testing. Until I was documenting my tool, I didn't realize it. And it would have been better if I had had a tester working with me testing my own stuff, but I didn't. It was just me. So that documentation step for me helped me identify that I had forgotten to test if the power on this medical device ever turned off. I just didn't test it until, it's a very basic kind of test, but it never occurred to me until I was documenting and I was telling all the things that it did. And that's when it drifted into my head. Hey, how do I know this thing ever turns off after the end of the therapy? I never checked. And I keep going back to that example because it's a huge thing that I missed. And if I hadn't been forced to write that documentation to get specific about things, I would have been embarrassed when the FDA had discovered this hole in my test strategy. Of course, another lesson there is, boy, if I'd had someone to work with who was testing my work, then maybe that person would have noticed. Yeah. And that's what their job is. And what happens when I get into a coding mentality is my mentality becomes accomplish the mission, like finish the code, do the thing. And I stop daydreaming about all the things that might go wrong. As a tester, my job is to daydream a lot about all the things that could go wrong. But I can't be that way as a developer because I have to write the code. I have to get things done. So it is tough to have both those in the same person at the same time.
Absolutely, absolutely, James. It was a great session, James. Thank you so much for your time, and I'm sure that the people found it really enlightening. And I'm going to hand it over to Subhendu to close the session.
Yeah, thank you so much, Kalyan. Thank you, James. I think there is a little echo. If you could just mute yourself. Yeah. Absolutely incredible session. Today we had an amazing number of people. If you look at the kind of questions which we have received, the number of questions, very, very engaging. Thanks to Kalyan, thanks to James. To all the attendees, we have noted down all of your questions. We are already on the top of the hour, so we will probably take all these questions and request the speakers to respond to them over email. If you have any further questions for the speakers or for us, do send in an email to marketing@signity.com. We would absolutely get in touch with you with the responses. Thank you so much, everyone. Have a wonderful day.